Hello everyone, I am Pawan Asava. Welcome back. So we have already discussed about Modbus communication parameters. So to communicate between PLC and VFD, first of all we will connect these devices using two wires. Okay, and here you can see this is the COM port 2 RS485. Okay, and these parameters will be entered in the VFD for Modbus communication. Here you can see this parameter will be 3 for RS485 communication input for VFD. Okay, and this parameter will be 3 means RS485 communication for operation command, means start, stop, forward, reverse. And this parameter of VFD will be 09.00, value will be 1. Okay, this is the slave address of HMI. Here PLC will be master, because we will control this VFD using this PLC, and this VFD will be act like slave, and we will enter slave address 1. Okay, next, this is the baud rate or communication speed between these two devices, PLC and HMI, during Modbus communication. And this last parameter for Modbus communication is about data bit length 7, parity no, stop bits 2, and we will transmit information using ASCII mode, Modbus ASCII. Okay, so for this setting we have to enter 0 in this parameter, 09.04. Okay, this way we will enter all the Modbus communication parameter and other setting parameters in VFD. Okay, now we will understand how to write PLC program in this PLC for Modbus communication. Okay, I will guide you completely about it. Here you can see we have write this PLC program for Modbus communication in Delta PLC. Here the PLC model is DVP ES2. Okay, but in your case the PLC model may be different, so we can modify this program if we need. Okay, if the PLC model you are using is different. Okay, to change the PLC model you can go option and click here change PLC tab, and you can select any PLC. Okay, suppose if you have PLC SS2, then you will select SS2 from here. Okay, but for now I am using ES to PLC. Okay. First of all, we will check PLC communication with laptop for PLC programming. Okay. So now PLC to PC communication cable is not connected. I am connecting okay. I am connecting and connected. Here now you can select this port, serial port for programming. Okay. Now we will understand this PLC program for Modbus communication. Okay. Basically this is the program for Modbus communication using COM port 2 of PLC. Okay. So before I have told you the Modbus communication parameters are only 4, that is baud rate, parity, stop bit and data length. Okay. The data entered in VFD you can see here. Here baud rate is 9600. Okay. And bit length 7. Okay. Bit length 7. Actually these two parameters, last two parameters are Modbus parameters, baud rate and data length 7, no parity, and 2 is the stop bit and Modbus ASCII. Okay. Please remember this. Actually we will use this setting in programming. Okay. Here you can see PLC program again. So you can see this PLC program. Okay. I will again take these 3 rungs again to make you understand about Modbus communication with VFD. Okay. Suppose I am deleting it. Okay. Now we will go to the wizard communication program. Here we have to select a communication port of a PLC for Modbus communication. As I have told you, and you can see I have used COM port 2 for Modbus communication in my PLC. Okay. In SS2 model of Delta PLC you can use this port also, COM port 2 for Modbus communication, and press next. Here we will take any memory bit. Okay, I have taken it, special memory bit, and these 4 are the weight. These 4 are the Modbus communication parameter. Data length 7, because in a VFD we have already entered data length 7, and parity bit check no, none, and stop bit 2. Okay. In the VFD these parameters are same. Okay. And baud rate is 9600. Okay. Everything is okay. Now press next. Again next. Okay. Now this is the program for Modbus communication using Component 2 of PLC. Okay, I will compile this section. Okay, and here we will set this bit M1122 for sending request. Okay, and this is the special memory bit of PLC. Okay, I am explaining this program. After understanding, you can use the same program in your PLC for Modbus communication, and your device, I mean PLC, will perform Modbus communication with your VFD. Okay, next, here you can see this is the special memory bit in PLC, and this is the instruction for Modbus write read command. Okay, with this command you can write values in your VFD, and also you can read the values from your VFD. Okay, for values writing, we will write some values in VFD like start stop command, forward reverse command, and frequency. Okay, for speed. These parameters will be write to the VFD using this command. Okay, and some parameters of VFD like current monitor, voltage monitor, RPM monitor, frequency monitor. These parameters in VFD we will read in PLC. Okay, so now you can see this command. Okay, I will explain this command. Here I have already told you Modbus write read, and here K1 means it is the slave address of device for Modbus communication. Here in VFD we have entered slave ID 1 for Modbus communication, so we will write 1 here. Okay, and H2000, it is the data register of VFD. Okay, it is the data register of VFD to write commands like start stop forward reverse. Okay, in this data register H2000 we will write values using D10 of PLC. Okay, so here you can see for a forward direction we will move decimal value 18 in D10. Okay, then this D10 will be moved to the H2000. Okay, then this value available in D10 will be transferred to H2000. Okay, and for reverse direction we will move decimal value 34 to D10. Then if we press reverse command, then value in D10 will be transferred to H2000. Okay, this is for forward and reverse. And for stop we will move value k1 decimal 1 to the d10. Okay, and d10 again will move this value to S2000 again to stop VFD. Okay, and during stop we will reset M10 and M12. Means if we will press a stop button, then forward and reverse command will be reset. Okay, so it was about operation of VFD: start, stop, forward, reverse. Okay, now you should have doubt about these values 18, 34 and 1. Okay, why I am moving only these counts? Okay, so I will explain this to you, don't worry. Here you can see this data register in the VFD to write Modbus command. Okay, and this data register have total 16 bits. Okay, and these are the bits. Okay, these are the 16 bits. Bits are starting from V0, okay, and going to B15. Okay, it means total bits are 16, and these bits of this data register means from B8 to B15, these are reserved. Means you can't use these bits. Okay, can't use means these bits will be 0. Means the values of bits from ranging B8 to B15 will be 0. Okay, in this data register 2000H, and these two bits B0 and V1. Okay, these two bits, these are the combination of these two bits. If these two bits are 0, it means no function. If this bit is 0 and this is 1, okay, for this code. To stop command, we will send 0 here and 1 here. Okay, understand? And for run command, we will send 1 0, means 1 here and 0 here. Okay, and after this these two bits are reserved. Okay, you can't use these bits for modification. Okay, and these two bits B4 and B5 of this data register 2000H, the combination of these bits are given below. For both bits are 0, it means no function. Okay, if you want to give forward command, then you need this combination 0 and 1. like this. Okay, but if you want reverse direction, then for reverse direction, this combination 1 0 like this. Okay, and for change direction you can use both bits 1. Okay, and after these two bits, B7 and B6. Okay, these bits are for acceleration or for acceleration and deceleration, but we are not using these bits. Okay, or you can say we are using this combination, first step acceleration, deceleration. Okay, hope you are understanding it. Okay, now suppose if you want this VFD to run in forward direction, before run I will explain stop. If you want to stop this VFD, then we will use these 16 combination of bits. Okay, so if you write this code here, then it will be 0 0 0 1. Okay, it means, and this is hex value. Okay, if we convert this value in decimal, this will be 1. Okay, this will be 1 for this combination. It means to stop VFD, we will move 1 into 2000 H data register. Okay, so you can see here in PLC, here wait, here we are move K1 to D10. Here you can see or D10 again sending this value to H2000. Okay, it means if you want to stop your VFD, then you will move decimal 1 into the H2000. Okay, using D10. Now if you want this drive for forward direction and run. Okay, suppose now we want direction of VFD forward and want to run command. Okay, then for forward direction we will use this code here on B5 and B4, and for run command we need 1 0. Okay, and other bits of this data register 2000 H will be 0. Okay, so the value will be like this: 0 1 0 0 1 0. Okay, then if you convert this value, this is the binary. Okay, we are not writing other bits below 0 because there is no importance of writing these value because all are 0. Okay, so if we convert this value in decimal, we will get 18. Okay, in decimal. So we are moving 18 value to the 2000H for forward direction. Okay, so if we move this value 18 to the 2000H, the VFD direction will be forward and operation will be run. Okay, this way. So in PLC we are moving value 18, move 18 to D10 and D10 moving to 2000H. This way this forward direction command is going to the VFD. Okay, again for reverse direction we will move value 34 to the D10 and D10 again moving to H2000. Okay, but how this 34 value is generated I will show you. Here you can see, sorry, for reverse direction we will use this combination of 16 bits. Okay, for reverse direction we are using this code 10 here. Okay, and for run we are using 1 or 0 here. So if we will write these combination here 1 0 0 0 1 0. Okay, this is the binary number. If we convert this value in decimal number we will get value 34. Hence we are moving 34 value for forward run, sorry, for reverse run in PLC program. You can see. Okay, this value 34 means we are moving value 34 to D10 and D10 again moving to H2000. Okay, and H2000 is the for commanding VFD. Okay, or we will write command operation command, because we are sending operation command using H2000. Okay, but you can doubt why we are using H2000. We are not using H2000 by chance, because this H2000 is mentioned in the PDF or user manual of VFD. I can show you. This is the user manual of VFD. For Modbus Communication, you need to check these user manuals of devices. If we search here 2000, suppose, okay, this is already open. Here you can see this is the 2000H and these are the bit combination. Okay, Okay, you can see here actually we have generated these 16 bits from here, this data of VFD user manual. Okay, and again you can see here for frequency transfer to VFD we need to use this data register 2001H. Okay, you can read here 2001H is for frequency command. So in a PLC program we use this command. You can see okay, here again Modbus write K1 means the slave ID of the device VFD is 1. H2001 is the Modbus address for frequency of a VFD, and D12 is the register of PLC to move frequency value in the VFD. Okay, so it was all about Modbus program for PLC to communicate between Delta PLC and Delta VFD. Okay, I will send you this PLC program to you. Okay, and you can use this PLC program for Modbus communication programming. Okay, now I am writing this PLC program to the PLC. Okay, communication setting is okay this way. Okay, online mode. Okay, wait, I am showing you the video of VFD and PLC, how they are working and how motor is rotating. Here you can see this is the frequency of VFD. Okay, 0.0. Actually we didn't enter any frequency in PLC program. Suppose now we are entering some PLC, so some frequency in VFD. Okay, we will enter here. You can enter this value also from HMI. Suppose we are entering frequency 10 Hz. Okay. Now you can see this value move to the VFD. Okay. Suppose again if we change this value K15. Okay. Now value have been changed. Okay. So this way we can change the frequency of this VFD using data register D8 in PLC. Okay, we multiplied this value by 100 and this final value is D12 and this D12 is moving to H2001. Okay, so this H2001 for frequency command to the VFD. Now we will start this motor, or we are sending forward command to the VFD. Set on. Now you can see the motor is rotating in forward direction. This forward direction is the clockwise direction. Suppose if you want to change the direction of PLC, stop. We press stop. Okay, now we will turn on PLC in reverse direction. Now motor is running in reverse direction. You can see anti-clockwise direction. Suppose now we will try to change the frequency from here K10. This way we have changed the frequency of VFD and speed of motor have been changed. You can see. Okay, this is the motor and this is the gearbox we are using. So this way you can run your VFD using your Delta PLC, and you can use any VFD. Okay, but in case if you change the VFD, then you have to check command word and frequency word. Okay, these two information data registers from VFD. Okay, and you can get these information from the user manual of VFD, and this way you can control any VFD using Delta PLC. Okay, hope you understand it, and I will send you this PLC program to you, so you can use the same PLC program in your PLC. But you know, I have already explained this PLC program to you. If you want to create this PLC program, you can create. Okay, here I am turn off this VFD using force inputs or by laptop. You can use push buttons or HMI for the forward reverse command to the VFD, frequency command to the VFD. Okay, so I think you got it. Okay, so thanks for watching, and tell me if you have any doubt after this video lecture. Okay, thank you.